All right, so example 5 is very similar to example 3, where we had the square root on both sides, but this time we have different roots on both sides. So for example, the first one, we have the cube root of 4x minus 1 equals the cube root of 6x plus 7. So if I want to eliminate these cube roots, I need to cube both sides, or take both sides to the power of 3. That's going to eliminate the radicals here, because I'm taking both sides to the same power as those roots. So that gives me 4x minus 1 equals 6x plus 7. Since I have x's on both sides, I want to eliminate one of them. I would probably start by subtracting 4x on both sides to cancel out with the 4x here, giving me negative 1 equals 6x minus 4x is 2x plus 7. Then we would subtract 7 from both sides in order to cancel out with the plus 7, giving me negative 1 minus 7 is negative 8 equals 2x. And then we can divide by 2 to eliminate the 2 in front of the x, giving me x equals negative 4. Similarly for the next one, here we are taking the fifth root on both sides. So we have the fifth root of 4x minus 4 and the fifth root of x plus 8. So I can eliminate those radicals by taking both sides to the fifth power. Again, making sure that the power matches the root. That eliminates the radicals on both sides, so that gives me 4x minus 4 equals x plus 8. Having x on both sides, I'd want to cancel one of them out, so x minus x eliminates itself. 4x minus x is 3x, minus 4 equals 8. I would then add 4 to both sides to cancel out the minus 4, giving me 3x equals 12. We then divide by 3 in order to cancel out with the coefficient of 3, and that gives me x equals, once it saves. Well, looks like it reset itself once again, but we had 3x equals 12 divided by 3, and that gives me x equals 4. If you need the rest of that work here, you'll just have to rewind the video to go back to find it. But that is all for example 5.